Every model begins with data, and when it comes to crime analytics, that data doesn't just describe what happened, it defines what gets counted as crime in the first place. If predictive policing is the algorithmic brain, crime data is its memory. And like all memories, it's selective. So, what exactly goes into a crime data set? At its core, we have three main sources. Number one is incident reports. These are filed when an officer documents a crime. Number two is calls for service. These are those 911 calls and dispatch logs that record where, when, and why people ask for help. And number three is arrest data. This is who was taken into custody, where, and under what circumstances. Add in supplemental sources, like traffic stops, field interviews, or even community watch data. And you start to see how wide the funnel really is. But here's the catch. Each of these sources depends on human behavior. People have to call, officers have to respond, records have to be entered. So the data is not a mirror of crime, it's a record of criminal activity that passed through official channels. When we talk about crime data, it helps to separate two big ideas: data collection and data harvesting. Data collection is the intentional process. What happens when agencies design systems to gather specific information? Think of officers filling out reports, dispatchers entering 911 calls, or analysts logging evidence into a case management system. Each data point has a purpose, a protocol, and a paper trail. Data harvesting, on the other hand, is what happens when systems start gathering data automatically, often without direct human input or awareness. License plate readers scanning every car that passes, ShotSpotter microphones detecting possible gunfire, security cameras feeding live video into analytics software. Harvesting expands the reach of policing data far beyond what was once logged manually. But it also raises bigger questions about consent, privacy, and oversight, because when a city deploys sensors or analytics tools that record continuously, the result isn't just collected data, it's harvested behavior. Once an incident is logged, whether it's collected or harvested, it has to be coded. That's where the Uniform Crime Reporting System, or UCR, comes in. The national standard that defines categories like burglary, assault, or theft. In recent years, most agencies have shifted to NIBRS, the National Incident-Based Reporting System, which captures much more detail, up to 50 data fields per case. Because not every officer, agency, or software system classifies incidents in exactly the same way. If one department codes an incident as aggravated assault and another calls it simple assault, that tiny difference can ripple through a model's predictions. Crime data is inherently spatial and temporal, where something happened and when. To make that usable for analytics, each incident is geocoded, mapped to a latitude and longitude. Sometimes that's precise, like 123 Main Street. Sometimes it's vague, like near Elm and 5th. Then analysts group events into units: grid cells, patrol beats, census tracts, or neighborhoods. The choice of scale matters. A model built on 500-foot grids might tell a very different story than one built on zip codes. And time works the same way. Do you model daily incidents? Weekly? Monthly? Each decision smooths over some noise and hides some nuance. Modern crime analytics rarely stop at police records. Analysts now integrate environmental and socioeconomic data to explain or predict patterns. Common examples include census data, which is income, unemployment, or population density. Then there is zoning and land use maps, which might include bars, schools, parks, and then we have lighting data or business permits. And also we might have weather, holidays, and even major events. Each added layer gives the model more context, but also more opportunities for bias. For example, if low-income areas have more calls for service simply because residents rely more on 911, a model could mistake need for risk. Crime data is not neutral. It reflects decisions: who gets patrolled, who gets reported, who gets arrested. If certain communities experience more police presence, they naturally generate more data points. Feed that into a model and the algorithm might say, this neighborhood has higher crime risk. But really it's just saying, this neighborhood has higher police visibility. That's how feedback loops start. Models learning patterns from history, then reinforcing them in practice. Good analysts know this and test for it. By comparing reported crime to victimization surveys, population data, or independent audits. And here's where the difference between collection and harvesting becomes even more important. Collected data is visible. You know who entered it and why. Harvested data often isn't. It can come from private companies, security footage, predictive sensors, or third-party analytics platforms. When cities buy or license harvested data, They inherit its blind spots without always knowing how it was gathered. Was consent given? Were biases introduced upstream? And once harvested data feeds a model, it's nearly impossible to trace those influences backward. That's why transparency about data origins is as important as transparency about the algorithm itself. In recent years, many cities, including Chicago, Los Angeles, and New York, have made portions of their crime data public. These open data portals allow researchers, journalists, and citizens to analyze patterns for themselves. It's a huge step for transparency. But even open data needs context. Missing fields, anonymization, and inconsistent reporting can distort conclusions if we treat it like gospel. Data empowers us, but only when we understand its boundaries. So the next time you see a crime heat map, remember, every pixel represents layers of decisions. What was seen, what was recorded, and what was captured automatically. In the next episode, we'll explore what happens after the data is collected, how it's modeled, tested, and sometimes misused in the name of prediction.